Okay, so Michael, in the spirit of what we just went through in deriving the geometric series, I'm now going to write down a bunch of math. And what I'm going to do is I'm just going to say it at you, and you're going to interrupt me if it doesn't make sense. Okay?
That makes sense.
It does. Okay, so here's the first thing I'm going to write down. I've decided that by going through this exercise um, of utilities and discounted reward, we can now write down what the optimal policy is. The optimal policy, which as you recall is simply pi star, is simply the one that maximizes our long-term expected reward, which looks like what? Well, it looks like this. There, does that make sense?
Let me think. So we have an expected value of the sum of the discounted rewards at time t, and given pi, meaning that we're going to be following pi.
Mm-hmm. So these are the sequence of states we're going to see in a world where we follow pi. And it's an expectation because things are non-deterministic or maybe non-deterministic.
And do we know which state we start in?
It doesn't matter. It's whatever S0 is.
I see. Whatever S0 is. But isn't that random? I mean, S1 and S2, S3, those are all random.
Well, we start in some state. It doesn't matter. So t is starting out at 0 and going to infinity. Okay? So does this make sense?
Yeah, so we're saying I would like to know the policy that maximizes the value of that expression.
Right.
So it gives us the highest expected reward.
Right.
Yeah, that's the kind of policy I would want.
Exactly. So good. We're done. We know what the optimal policy is, except that it's not really clear what to do with this. All we've really done is written down what we knew it was we were trying to solve. But it turns out that we've defined utility in such a way that it's going to help us to solve this. So let me write that down as well. I'm going to say that the utility of a particular sequence, of a particular state, okay? Well, it's going to depend upon the policy that we're following. So I'm going to rewrite the utility to take as a superscript pi. And that's simply going to be the expected set of states that I'm going to see from that point on, given that I follow a policy. There, does that make sense?
Feels like the same thing. I guess the difference now is that we're saying the utility of the policy at a state is what happens if we start running from that state.
Yep, and we follow that policy.
Got it.
Right? So this answers the question you asked me before about, well, what's S0? Well, we talk about that in terms of the utility of a state. So how good is it to be in some state? Well, it's exactly as good to be in that state as what we will expect to see from that point on, given that we're following a specific policy where we started in that state. Does that make sense?
Okay. Yeah.
Very important point here, Michael, is that the reward for entering a state is not the same thing as the utility for that state, right? And that in particular, what reward gives us is immediate gratification or immediate feedback. Okay? But utility gives us long-term feedback. Does that make sense? So when a reward for a state is the actual value that we get for being in that state, the utility for a state is both the reward that we get for that state, but also all the reward that we're going to get from that point on.
I see. So, yeah, that seems like a really important difference. Like if I say, here's $1, would you poke the president of your university in the eye? You'd be like, okay, the immediate reward for that is 1, but the long-term utility of that could be actually quite low.
Right. On the other hand, I say, well, why don't you go to college? And you say, but that's going to cost me $40,000. Or better yet, why don't you get a master's degree in computer science from Georgia Tech? And you say, but that's going to cost me $6,600. Yes, but at the end of it, you will have a degree. And by the way, it turns out that the average starting salary for people getting our master's degree versus our undergraduate degree is about $45,000.
So is it considered product placement if you plug your own product within the product itself?
No, I'm just simply stating facts, Michael. This is all I'm doing. It's just facts.
All right.
This is called fact
All right.
placement. The point is, there's an immediate negative reward of, say, $6,600 for going through a degree, or maybe it's $10,000 by the time the 15th person sees this. But anyway, it's some cost. But presumably it's okay to go to college or go to grad school or whatever, because at the end of it, you're going to get something positive out of it. So it's not just that it says it prevents you from taking short-term positive things if that's going to lead to long-term negative things. It also allows you to take short-term negatives if it's going to lead to long-term positives.
That makes sense.
Right. And what this does is this gets us back to what I mentioned earlier, which is this notion of delayed reward. So we have this notion of reward, but utilities are really about accounting for all delayed rewards. And if you think about that, I think you can begin to see how, given you have a mathematical expression for delayed rewards, you will be able to start dealing with the credit assignment problem.
Cool.
Okay, so let's keep going and write more equations.